All right, so welcome everyone. As Arjen said, my name's Dave Hall, and I'm going to be talking about collect, detect, and react, building a low-code automation platform on AWS, obviously being Community Day. But first, before I get into my presentation, I want to jump in a time machine and go back and look at how we got here and how that can actually help us to figure out how we're going to build our platform. So let's jump back. We'll jump back a bit. And so humans have always been innovating, inventing, trying new things. And so I think that that is a really good way for building automation as well. So let's look at a few other things that have helped contribute to this. So I've got another time machine, and we're going to jump forward a bit further. And here we have the printing press. And the printing press helped accelerate the sharing of ideas. For most of us, we share ideas using the internet these days. Back in the past, we used a printing press. Let's jump in our time machine again, and we'll jump forward a bit further. And we had Steam, and things started really chugging along once we got Steam. This allowed us to start to actually build things that were powered. So let's jump forward a bit further again in another time machine. I've got plenty of time machines. Now this time, some bright sparks discovered electricity, and electricity helped power things. Yeah, good. One person got it. So electricity, that's powering so many things in our lives today. Yes, the time machine references are getting more obscure because it turns out there's not that many movies with time machines. But we'll ride in this one. We'll jump forward a bit further. We then get computers. Now, this is CIRAC, which was the fourth memory computer and the first one in Australia. Just a few facts on this one, because I think it's really interesting. It ran at 1 kilohertz. It had 1K of memory and 5K of disk. Sorry, 2K of memory, 5K of disk, and it burnt 30 kilowatts per hour to do computation. So people who are worried about the power consumption of AI these days, this thing was way less efficient. Now, today, we have something like this. Runs at 1.2 gigahertz, and it is 64 meg of memory, 128 meg of storage. You can stick an SD card in it with up to 4 gig of storage. It fits in a matchbox and costs you less than $2 delivered from China. So this thing is, and it uses less than 1 watt of power at full load. So this thing is way more powerful. So our technology, we keep innovating, things keep getting smaller, better, more efficient. So this is a real time machine. There will be a quiz at the end. So if you know which movie it's from, you can come tell me. Now, in the 90s, the information superhighway was the big thing. This was Time magazine, April 1993 was the front page. They were very excited about it. Let's fast forward, just as an aside, let's fast forward 11,000 days, and this was Time magazine's take on the hype technology of the day. I suspect that the journalist who wrote that was a bit worried about their job. So, one more time machine. I had to go in. So, eventually we get to having events. Actually, not that type of event. These types of events. This is how we track when things change in our systems. In this example, it's an issue being edited on GitHub. And so every time something changes in GitHub, you can get an event. And in so many different systems, they emit events sometimes through webhooks, sometimes through GraphQL APIs, sometimes you can get direct feeds. So there's various ways of doing it. But events are going to be one of the key bits of our platform. Now, these events, we don't want to just store them. There's no point in storing them. You know, they're not Pokemon. You don't need to collect them all and store them and go back and look at them. You actually want to consume your events. And so that's what we'll talk about, how to build a platform to consume these events. So you're probably wondering how. So how we do it is we're going to build a platform. Now, anyone here work in the enterprise? I know some of you do. So, enterprise people, we're building a platform, not a whole train station that takes several years and burns loads of money and probably gets canned in the next budget review. We just want to build the platform part of things here. And it should be small, it should be scrappy, it should be functional. It doesn't need to be this grand building that, you know, people meet under the clocks if you're from Melbourne. You know, platform's good enough. And the platform should be about democratizing automation. It should be built in such a way that everyone from our organization can take advantage of it. It shouldn't just be one automation team. They do all the automation and you wait 6 months and they build it wrong anyway. Not talking about personal experience at all. So the first bit of building our platform, we want to collect our events. So let's look at how we collect our events. Well, you might be thinking, how do we do it? Let's use a bus. And so Amazon gives us a managed bus in EventBridge. And so EventBridge comes with loads of integrations built in. So if you use PagerDuty, if you use Okta for ID, sorry, I probably should have put Auth0 up there, given they're a sponsor. Plug in the sponsors. Salesforce has a native integration, Stripe has an integration, ChargeBee, Twilio, the list goes on and on. Just as a side note, Zendesk has actually pulled their native integration. Who knows why? Private equity, yay. But I'm not bitter. But these native integrations make it really easy to integrate stuff into EventBridge. You don't need to build the code, it just comes ready to go. Now, there are some integrations that Amazon provides that you just run the CloudFormation stack and it will do the integration. So that works for GitHub, GitLab. There was one other, and it used to work for Stripe, but now Stripe's a native integration. So they can help. The rest, you need to do it yourself, and we'll talk about that in a minute. But the big advantages of EventBridge is value for money. 1 million events cost you $1 US. So it's super cheap to get the events into the bus. Part of the reason why I had so many time machines is you can do event archive and replay, which effectively lets you do time travel with your events and your data over time. And finally, the default bus, everything that changes in your AWS account, well, almost everything that changes, you can get an event on the event bus as well. So not only can you use this for monitoring, for acting on events out in the real world, you can also do it in your safe little AWS world. Now, we want to have multiple buses. So say AWS, we want a bus that is going to integrate with the default bus. That comes out of the box, it's already in your account, go play with it. Then with GitHub, we'll have a bus that we set up which is dedicated for our GitHub events. This, you can use the CloudFormation stack I mentioned earlier, And maybe you've got your internal application. For that one, provision of bus for that application. So you can separate stuff out by individual buses. Individual teams can own those buses. So maybe the Cloud Ops team might own the default bus. Your GitHub one's probably going to be owned by the team that manages GitHub. Or if you're in a small organisation, that's going to be the same person. And the team that builds the internal app, they should own and manage that bus. Now, how do we use this for our automations? We add another bus. And this time we have our automation bus. And we can actually send our events from the GitHub bus to the automation bus. And we'll talk about how we do that in a minute. But having these separate buses and having distinct owners makes it a lot easier for managing stuff over time. Because remember, if everyone owns it, no one really owns it. So detections. So let's have a look at how we can do detections with this. So we can do them with EventBridge, and EventBridge has rules. So say we've got an example service, because examples are great, and we have an event name that's event name. I put a lot of thought into this one. And then we have a failed state for our event. So we just want to know when our example service failed. We can emit events. We use this rule to match those events. And then we can feed it onto our detection stage, which we'll talk about in a minute. The other option is sometimes we don't have enough context. So we might need to add additional context. So we can actually enrich our events here. And so how we do the enrichment is with a step function. So for example, we might have additional data in DynamoDB. When we have the event come in, we kick off a step function. The step function grabs that extra bit of data. Then we've got a choice. Is this something we care about? If no, we just stop. If it is, we emit another event and then it goes back into the bus and we can handle it from there. And we'll talk about why we don't continue with the reaction step in a little bit, but we're trying to decouple things. Those of you who have built complex applications, you know all about separation of concerns. That's applying the same principle to automation here. Now, let's have a look at our reactions, or these people kind of failed with their reactions. I'll show you how to do a better job of reactions. So, step functions is a key part of reactions. And step functions, you can build really complex workflows or really simple workflows. It's up to you and your imagination and how much you love debugging crazy stuff at 2 o'clock in the morning. Try to keep it simple, you'll sleep better. So our first example, we've got a GitHub repo that's going to be made public. Now, if you work in a large organisation, your legal department would freak out if you were making stuff public that should not be public, especially if it contains sensitive stuff. Your security team's also going to freak out. So what we want to do is make sure that we never have public GitHub repos. So how we do that, we have our collect, our detect, and our react phase. So let's have a look at collect. So all of our events come in from GitHub. This is just feeding into our GitHub bus. The events are coming in, and now we need a detection. So on our event bus, this is going over to our automation bus, where we have a rule which is looking for, is there a new repo? And then what we do is we kick off the step function, and it actually goes and updates GitHub again. So let's have a look at this in more detail. So collect, public repo created, the event fires, that feeds into a Lambda function with a URL, again, provision using CloudFormation, so we don't have to worry about that code. and goes to the GitHub bus and over to the automation bus. Now, on our detection, we have our automation bus with the detection rule, and this is our detection. So if the source is GitHub, the detail type is a repository, and the flag for being private is false, we know that this needs to change. So what we do, we have a reaction, which is just this step function. All it's going to do is to call the GitHub API and flip the bit for private to true, and that makes the repo private. Generally, you're looking at seconds from someone creating that repo to it being made private. Now, people can keep going back going, I really want this to be public. They're going to go crazy because the automation is just going to keep flipping that bit back. Now, let's have a look at going the other way. I really like GitHub, so another GitHub example. So we're going to manage the admins for our GitHub organization in SSM parameter store. And the reason for doing this is if someone goes and adds an admin to the GitHub organization that they shouldn't have, that can cause problems. So this way we have a proper process to manage our admins. So again, collect, detect, react. So our collect phase, every time SSM parameter store gets updated with a new value in the list, that's going to fire an event. We have our bus with the rule, and then our reaction is going to be a step function again that goes and updates GitHub. So let's break it down. So SSM fires the event, goes to the default bus with all the other AWS events. We then route that over to the automation bus. And then for detect on the automation bus, we need to do some enrichment. So this is going to call a step function. So the first thing it's going to do is to get the current value of the list out of SSM, because it turns out the event doesn't actually give you the payload from SSM parameter store, because SSM parameter store can contain sensitive data and you don't want that sprayed across all of your buses. So we pull the value, then the next thing is we want to get the current members of our GitHub organization. Then we can actually run the rest. Actually, let me zoom this in for you. Then we want to run this in parallel. So we have a loop where we check if there are any admins to add. If there is, we fire an event for each new one. The same for any admins that need to be offboarded. We just run them through a loop, emitting an event. Once we've run out of people, we just finish. So React, it's just a Lambda function, add an admin. Really simple, just one step, and it's done. Now, if this is all being done by one team, that team starts to become a bottleneck. And it also means that, say for example, we've got a team, like someone who's an owner, they're like, we really should have all the owners in a Slack channel so we can talk about how awful our users are. That's what admins love doing. So what we want to do is actually split this, we want to have a workflow for handling that, but that's going to be handled by a separate team. So we can actually build our own extension to this workflow. And what we do is we have another step function that gets invoked, and we can get the user's profile when they're added as an admin, get their GitHub profile, extract the email address, call the Slack API, look up their profile, their email address in Slack, and add them to the right team. So this way, this workflow runs completely independently of the workflow that's maintaining the state in GitHub. So it allows different teams and different people to build those automations. Now, this, I promise, is the last time machine for the day. We're going to jump back and do a quick recap on what we've covered today. So have buses, have lots of buses. Use buses to keep things separate. Have owners for each of your buses. It just helps keep things organised. Give each of your applications a bus. I know in my diagram I had one automation bus, but give each team their own automation bus. The buses are free. In Brisbane, they're 50 cents. It's even cheaper on AWS. They're completely free. You only pay for the events that you run through them. So please take advantage of that. And build detections. Spend time planning your detections. Elliot talked about spending over 50% of their time planning. Like planning your events, planning your automation, planning your detections. It'll save you time later on. And if you build your reactions right, your end users are going to be surprised in a good way all the time. So put the effort in up front and make sure that your reactions are just doing one thing. If you're finding that you've got a really long workflow as a reaction, you're probably doing too much. Split up into two. They can run in parallel. You can even have different teams managing them. And keep innovating, keep learning, keep trying new things. If humans didn't do that, we'd still be sitting in caves in the dark. So, get out of the cave, build some cool stuff. So, thank you very much. Now, the organisers have told me that you have to give me really good ratings for my session. So please go here and do that. It'll make them happy and it'll also make me happy. And if you like this type of stuff, I do have a newsletter that I publish sporadically because I spend too much time doing other stuff, but I will be hopefully publishing more stuff on this soon. So please subscribe. So